We are going to see this morning how you handle transfer functions in Simulink. But before you do that, we need to have the transfer functions. So what I outlined for you here as we start this objective is to have the simple circuit that we were talking about in previous lectures. And first of all, find the transfer function. So the plan is go over of the different ways that we obtain the transfer functions, and then see how we can use these transfer functions in Simulink. So that's one alternative, is if you have the transfer function, then handle that in Simulink. The other alternative is to have CAMG directly generate the transfer function in Simulink, and that would be the two objectives that we have. So let's get started here. We see in here the circuit, and you have the outputs define the voltage across this capacitor and the voltage across the resistor as the ones that we want to find out. So we can operate with these two transfer functions. But to make life a little easier, let's just pick just one to begin with. Let me just go over the options that you have in generating the transfer functions. The very first option is this one. This we obtain by hand. How do we do this? We derive the equations of motion, um, and we obtain this transfer function. Perhaps it might not be a bad idea if I remind you of that. Maybe we go back over here. There we go. See, we had, this is from a previous lecture. We had the circuit in here, and we apply, in other words, we define the differential equations in the time domain, and right after that, we apply the Laplace transform. So once we apply the Laplace transform to the equations and to the output, we had this situation where we have a system of equations, see, two equations, two unknowns, Q1 and Q2. And using Cramer's rule, we found Q1 and Q2 as, and using that, we found the voltage C in relationship to the input, and that's how we obtain this transfer function. So that's just as a reminder of what we had done in the past. So that's how we ended up over here. Okay, once we did this, we can directly use this result in Simulink. But I want to remind you of a couple of other options that you have, and that is to generate this in symbolic form using an algorithm that I had provided for you, a general algorithm that solves these two equations that we had in here, these equations that we had up here. Yeah, see these ones? So I had given you an algorithm that will solve this, that you can use it as a template and use it to solve any set of simultaneous differential equations, no, simultaneous algebraic equations in the S domain to obtain the transfer functions. And of course, there is option number 3, which is the computer-generated transfer function, and that is the one that I would like to go over now, and then let's go and see how we do that in Simulink. So I have entered this bond graph into the CAMG software, and I am going to go here, and I am going to generate the transfer functions for this by doing, in this case, to MATLAB first. So I go in here to MATLAB and have CAMG and MATLAB negotiate an interface, and I need to define as my output as ISO4 in here as the output. So when this comes up, I go and say in the ChemGSYM file, please find ISO4 as my output. And there it is. So in this, I need to define this as the output because otherwise we cannot generate the C and the D matrices because the computer process the bond graph model, but you need to tell it what the outputs are. So we have just done that. And if we run this in MATLAB, here's what will happen. The computer will generate the, let's tell you what the state variables are, the A matrix, the B matrix, the C, and the D, and of course, the transfer function. So I am going to put, to take just this little part of the screen and put it in our notes that we're making to show you that you can obtain the transfer function this way. Do you see it's the same thing? We did it by hand, we did it with the algorithm here, and this we did is a computer generated transfer function. You see I6 is L, and then you have C is C, I is L, R2 is R, I6 is L, and R2 is R, of course. So I know that by doing it three different ways, there's no question that this is the real transfer function. Okay, so what I was trying to say is that if we have this transfer function in symbolic form, we could use this transfer function in Simulink directly, either entering that transfer function into Simulink or using again our bond graph modeling approach. I think that because we would like to encourage everybody to do the automated way, I am going to use directly the transfer function in Simulink so that you can see how that works, okay? I think we have done this in symbolic form and now we have to do it in numerical form. So in this particular case, what we need to do is go back to the ChemG software so that we go over here and let's get started. Yeah, and then in here, this is our bond graph model. But I can go in here and do Simulink. Yeah. And the computer is going to give me some files in there in MATLAB, that those Simulink files. See, right here is going to, well, let's see what happens. Don't want to confuse the previous ones with this one. This were the ones of the, okay, let's just close this window. That was the symbolic one. This was the MATLAB one. And this is the Simulink one now. And this is what ChemG gives us. It gives you already a couple of models in Simulink, and this they have two options. One is the state space form, which we have seen in the past, and the other one is the transfer function, which is over here. What I'm going to do is we're going to work with this one, with the transfer function in here. ChemG, when you have this, generates two files, the initialization file and this numerical file. Okay, so in here, if you this is the to initialize the, this is the numerical file and this is the initialization file. So in here, you put the values, you see, and then, of course, you define the outputs, and you will obtain the matrices. But in this file, which is the one that we need, we will have to put the values of the parameters right here, right, to be able to obtain what we need. So in this case, I'll just do this as a 2, I believe. Don't remember exactly what we said last time, but I'm gonna try to do one about the same ones, or close to it. Well, let's just put those numbers, but also remember ISO4 is our output, you know. So we need to, because this is a separate file from the MATLAB, you need to define the same way as you did in MATLAB. In MATLAB, we were doing it symbolically. Now we are going to be doing it numerically. Okay, so if you do this, what will happen? You say run this, come genome. There's the D matrix, there's the transfer function matrix. Of course, this is the initialized, but you see in here, what will happen is we have already the program running to produce the body plots and to produce the step and impulse response for the transfer function. Right there is a step and input response for this. Okay. Okay, let me just put those away. But you see, these are the transfer functions, and the transfer function that we have is for the, let's see, where are we here? Yeah, this is the transfer function for the LS. So that's the transfer function that you're seeing here. But in here, when you click in here in this, do double click, there is the numerator and the denominator in here. Okay, these things have already been calculated for you, and what you need to do is simply this, you go over here and then you run it, and you should be able to, in other words, that numerator and the denominator were obtained using the matrices. So in here, if you go here and run, you should be able to obtain the in there you go. That's the same, this is the same response that we got over here, I believe, right there. See, this is the on doing it on the MATLAB side, this is doing it on the Simulink side. So once you have this initialized, the way it works is internally, if you look at the file, let's see here, if you look under, those are the matrices. Obtaining here the, this is the way you find the transfer function, okay? But this section here transforms that transfer function into the numerical one that you could actually use, see, right there. And right after that, we just do the step and the impulse response. But if you go just to the on the other there's two files that control the Simulink interface. This is the file that I told you does all those things. But this initialization file, the camgini, you put the numbers in here, you're going to get just the matrices in here. You have those initialized. Okay, so once you have them initialized, you can do it for the state space form. But this one, camgenum, is the one that actually allows you to do the, the transfer functions here. The interface with Simulink. Because what happens is in here, you see, the once you initialize the matrices, also initializes the transfer function. But whatever happens in the Simulink, in the MATLAB world, it happens on the Simulink side too, because they use the same workspace. So when you double click over here, this num in here and this den in here, this denominator, they are the ones that have been produced and initialized in this file right there. See, this is where we calculate the nums, the numerator and the denominator by using the values of what we had before. Once we had this transfer function in symbolic form, this part transforms it into the numerical side that is used over here. And that's how we obtain the response using doing in Simulink. Here, once it's like this, you can put it in any control system or anything that you want to do the transfer function. So hopefully that answers the question on how to handle the Simulink transfer functions, starting with the bond graph.